Welcome to the May meeting of the Town of Philipstown Conservation Board. I'll call the meeting to order. The first thing I'd like to do is approve minutes for both February and April. Could I have a motion to approve February's minutes?
Make a motion to approve the minutes of April.
Second? And all in favor?
Aye.
Aye. And April? May I have somebody make a motion, please? You weren't here. I think everybody else was, okay. Second? Tony?
I'll second.
Okay, all in favor? Aye. Okay. I thought we were going to have somebody here from Beatty and Watson representing Sadove and Zweibon, but it doesn't look like it, so let's move on to the next agenda item, which is Angel Vivar.
Good evening. Hi.
Hi.
So, yeah, we received your application to help rectify the violation for your property for a couple of different issues that were brought before the board's attention. The application is fairly incomplete, so we wanted to talk to you in front of the board and get kind of your perspective and your intention on what you wanted to see done on the property. And kind of walk through what the intention for the improvements that were done without a permit were. So if you could just kind of take us through what your thinking is, we can start to help work through this process with you.
Yeah, well, what I'm trying to do is just put some topsoil on there and just plant some grass on the yard, like on the left side and then on the right side.
So were there other issues that the board brought up that where there may be a commercial use like on the property that is the property being used in a commercial capacity at all for truck storage or anything like that, or that area that you've created?
No, I didn't create any area. It was like that already.
Okay.
Yeah.
I think what he's asking, are you running a business there?
No.
Okay.
Are you storing trucks there? Are you storing trucks overnight? Because I've seen trucks there on the property, yeah. I see it often there, yeah.
Yeah, sometimes when we make late ourselves, so we don't have a ride home, so we bring the truck and park there.
And how much topsoil was dumped in the area?
I still don't dump any.
No, there was
Isn't that
dump
like-
trucks of dirt brought into the
Oh, yeah,
area
yeah,
to fill
yeah.
it in and level it.
Yeah, well, I see on the sheet it says 100 yards, but I don't think it's 100 yards. It was less than that. I already moved up where I wanted to level it up a little bit the yard. So it's not close to the water. I'm not blocking the water course, nothing.
I mean, our concern is if you were making a lawn, we'd be a bit less concerned. But once it's being used as a parking area, particularly for any type of trucks or commercial vehicles, we are concerned about leakage in what could go into the, call it a compromised wetland that's in the area, but it's also part of a stream course that we need to protect. And that
What-
would be done very, very differently because there would be some form of a stormwater pollution prevention plan.
Yeah, well, if that's a problem, I cannot park my truck in there. I can park on the driveway. That's not a problem.
So, because you're gonna handle this, I assume, as a minor permit at this point?
Yeah, it'd be a
Right.
minor permit, but I wanted to open the discussion up regarding the intended use for the lawn area. I've talked with Andy preliminarily about having you do some native planting in between the wetland and the lawn itself.
Okay.
To kind of compensate for all the land that was cleared.
Yeah, that's our intention, yeah, because we don't like seeing that wetland
Yeah.
like on the side of the house.
Have you done an assessment, Max, so that area has been prone for the berm and the leakage coming from the berm when the water level rises and everything, and my recollection, that area floods and washes out, so I don't know with the raise and the topsoil, how that's going to happen, but it could be a mess. So I don't know if you've done an assessment of where the drainage might now go based on where that berm was?
No.
I mean, I have some pictures on my phone if you guys would like to see. I don't think it's gonna be any problems like washing the dirt because if if the water will, I mean, if the case that we're gonna have like a float or something, the water has plenty of room where to go through.
I
The
know,
area's flooded many times before when it's,
Yeah.
you know, I mean,
Yeah.
not every time, but when there's a lot of rain, so.
Yeah,
I know I had looked at, for a totally different reason, I'm gonna say about 2 years ago, there is a culvert pipe that goes underneath
there
Upland
is,
Drive.
yeah. The
And
pipe
it was occluded with a very large boulder. I don't know if, I know 2 of the neighbors had come out when I was looking at it, and they said they were gonna remove it.
Yeah,
Yes, I-
that pipe was all clogged
So-
up with
Yeah, so
rocks
if,
and everything. I cleaned and the water's going,
so that's,
Yeah.
that pipe now is
Yeah.
totally clear?
yeah, it's clean.
Okay, that's
Yeah.
good. That's very good.
I mean, in my opinion, I think moving forward with creating a native planting plan for, the yard space and memorializing that will only be used as a yard space is fine with me to begin to rectify the violation, but I would have to defer to the board as well if that was their thinking too. So,
Comments?
I'm okay with that.
I mean, I think that's an, you know, appropriate mitigation for the violation, because, I mean, technically, they should have come in and said, hey, we want to make this into a usable area. It's within 50 feet of the wetlands, you know, like, just, that's the process, you know, so if we can get back to the process and do it correctly and make sure that we don't create a new problem, that would be great.
yeah. And then we'll have to look and take consideration of the flooding issues potentially as well there, and just to make sure that the area can remain stabilized until it can establish itself. So if we can, I think again, your application, all you filled out was just the first sheet essentially. So if we can, I don't know if you have a site plan, that when you bought the home, if you have a survey of the property at all, do you have that readily available?
Site plan.
Like a survey?
No, I only have a few pictures that I got in here when I bought the property. That's all I have.
Okay. Well, maybe we can work together to come up with a planting plan, and then we can move from there. As long as the board's comfortable with the intended use that we discussed, I think we can handle it on our own from here out.
When you bought the property, I assume you had title insurance?
Yes.
So I would ask the title company, they probably have a survey,
Okay.
and to get it for them, it would make it much easier for Max.
All right. So I have to get the call the title insurance and then get the.
Yeah, I would assume that there is a survey sitting there. We're not asking you to go out and have a new survey.
Well, the county
So-
should have it as well.
It's possible, yes.
You can check as well with the building department.
I asked them. They told me that they don't have.
There's nothing in
They
your
only gave
file?
me a bunch of pictures that they have for the property, so
Okay.
that's what I have.
Okay.
And my neighbor was guiding me through where is our property and all that.
Right.
So
Well, until we can actually meet, maybe you can mark out in your property, in your lawn space where you intended on planting and where the spacing of the plants and all of that, and do that before I meet with you on the property, and we can discuss, kind of where to go back and forth on what you'd actually install there in the ground.
okay, how long does it gonna take that you can?
I'm available to come, so if you want to get started, and you have my cell phone number,
Okay.
yeah,
All right.
so we can do it fairly quickly.
Yeah, because I would like to finish that up
Yeah.
as soon as
Yeah.
possible.
Yeah.
Okay.
Sure.
Well, thank you so much.
Yeah.
Thank you for
All right.
coming in.
Thank you.
Good night. Okay, so we're going to open up a public hearing for the Walter Hoving Dam Removal Project and stream restoration. The agenda for it is Interfluve, which is the firm that's going to do the engineering, is going to present their plans so that everybody is familiar with them, and the board, once more, has time to listen and review. And then the town hired SLR Associates to do a peer review. And pretty much aligns with a few comments here or there, and they're going to present. After that, we're going to open it up to public comment. The hope at the end of this is that the board will be comfortable enough to put together a resolution that looks at this as an unlisted action and have a negative declaration under SEQA. What will happen then, if we do that and don't have to keep the public hearing opened, at which point, at the next meeting, we will vote on a resolution to accept the negative declaration and start assembling a permit with conditions. With that, somebody from Interflube, would you like to present to all of us? And I think this is particularly important to the public so they understand what is being done.
All right. Got it. Okay. Thank you very much for having me. My name is Nick Nelson. I'm a fluvial geomorphologist, which is a weird word for somebody who studies rivers and how they interact with the landscape. So I'm a scientist with a company called Interfluve, and we are a river and wetland restoration firm that works on streams, wetlands, estuaries throughout the country to consider ecological restoration, to consider repairing and recovering some of the function of our rivers and wetlands that have been damaged over time. I'm here today on behalf of Walter Hoving Home to talk about Phillips Brook and the dam removal on that particular property. This project is partially funded by the Hudson River Estuary Program as well, organization with the Department of Environmental Conservation. And we've been working with Walter Hoving Home for a number of years now, evaluating this site, trying to understand how this river works and how we can remove a failing piece of infrastructure and restore some of the connectivity of this river and stream. Apologize, it's hard to see you and see you all at the same time, so I'm a little bit torn here. I'm going to walk through this project, try to give an overview of where we are in the world, what the site looks like, what the goals of the project are, and then some of the analytical results, and then go through some of the design specifics as well. Just for background, we have been working on removal of dams that are no longer functioning for their original purpose for decades now. I'm based in Cambridge, Massachusetts, but I grew up visiting my grandparents just down the river here, Croton-on-Hudson. So it's great to be back here, but we've been doing a lot of fish passage projects in the northeastern part of the U.S. and throughout the country, trying to remove some of these old and unused dams that are starting to fail and starting to become a hazard for catastrophic failure. And so we've gone through this a number of times in Massachusetts and around New England. I've been doing this since 2007 or so. And so we've seen a wide range of types of dams, types of river systems in urban spaces, in rural spaces. And so we are able to come at this particular project trying to pull all that experience together. Recognizing that each project is different and unique, this one presents its own particular challenges, which we'll get to. So this map is showing the watershed of Phillips Brook upstream of the dam in question. The black dashed line is the boundary of the watershed where all of the water in that area flows into Phillips Brook and flows over the dam. The little inset aerial photograph up there shows Snake Hill Road running east to west, and Phillips Brook just north of that, flowing from the right side of the screen to the left side of the screen. And the Walter Hoving home property is on the north side of Snake Hill Road. Phillips Brook drains into Constitution Marsh along the Hudson River, so that's an important part of the Hudson River and plays an important role in filtering pollutants and floodwaters as they go into the Hudson River. This is a close-up of the project site. Again, the river is flowing from the right side of the screen to the left. The bridge going to the Walter Hoving home is shown on the right side of the screen there. And you can see the dam is indicated by the word dam, which is small. It's right around station 500 in the middle of the screen. Wish I had a pointer. And that's the main focus of this particular project. However, there are 3 other stone weirs along the river between the dam and Avery Road that are also failing. Those are small barriers, small dam structures. And there's stone walls all along the edge of the river. So the dam is about 10 feet tall. The current channel within those walls is about 15 feet wide. And this project encompasses about 800 feet of river channel. The entirety of the project will be held on the Hoving home property, including all of the access and staging components of it. So I'll look through some of the pictures here of the site. We can see the weir, one of the stone weirs on the left image there. You can see a lot of the damage that has occurred from the storms over time. Recent storms over the last few years. You can see some damage along the side of the wall there as well. In the right picture on the right is looking upstream towards the dam, which we can see in this picture here. This dam is not very good shape. You can see water coming through the stones. It is completely filled with sand and gravel and cobble, which a lot of that came in storms over the last few years. When we first started this project, the dam was mostly filled in with organic material and plants, some invasive plants. And then the big storms came through and loaded the impoundment up with gravels and cobbles. So it's not in good shape. And this is the reason that Beth and her organization approached us to look into options for this particular site to remove the liability and risk.
When you say that the dam was loaded with cobble and, silt and gravel, do you mean what was the kind of the pond behind it, or is it pushed up against the dam? And does pushing it up against the dam risk the dam or reinforce the dam?
Yeah, it's the whole impoundment is filled up. So there's water that's still flowing through, but what used to be a pond is now filled with gravel and cobble. Okay. I can't speak to how that's impacting the structural stability of the dam structure itself. It's in pretty bad shape, as you can see from those images. Mm-hmm. But if that dam were to fail catastrophically during a storm, all of that material, that gravel and cobble, would be washed downstream, right. Potentially occluding the Avery Road culvert and downstream properties.
Right.
So a few of the primary aims of this project: all dam owners hold liability associated with their dam. And so by removing the dam, that removes the liability concerns for Hoving home. It's no longer being used for its original purpose. The pond is no longer being used for recreation. So there's no use for the owner at this particular point. There's opportunity to reduce the public safety concerns from that catastrophic dam failure that we mentioned. Also, I'll show in a little bit the flooding that occurs currently. That floods over the road, Snake Hill Road, and Avery Road. So some of that flooding will change and reduce some of the flooding on Snake Hill Road. It will allow us to restore some of the natural stream processes, allowing fish and other organisms to move up and downstream through this section. It will improve the riverine and floodplain habitat through this area so that we have more natural channel bed and channel banks on either side. For the residents that stay at Hoving Home and for people in the area, we believe this will help to enhance the aesthetics, will help to improve opportunities for residents at Hoving Home to enjoy the stream here and enjoy the floodplain areas without risk. A few of the things that we've been doing over the last few years is conducting topographic surveys. We've subcontracted with cultural resources professionals to review the site for historical and archaeological sites and sensitivities. We did some sediment sampling of the material behind the dam. We have done a whole bunch of modeling of the water, where it's going to go, at what frequency, how high it's going to flood under existing conditions and proposed conditions. We looked at evaluating the planting plan that we should have on this site afterwards, and we've been going through some permitting over the last couple of years. So we have received the state permit for the dam removal project. We also received the U.S. Army Corps of Engineers permit last year. The Army Corps has changed their whole process, so that got renewed in March, and so we're reapplying for that now. So that's under consideration right now, and we're currently in the process of working with the town for the town and municipal permits. Looking at the design itself here, this is sort of a funny picture here that I'll try to interpret for you. Again, Phillips Brook is flowing from the right side of the screen to the left side of the screen. The dam is pretty much in the center of the image there. And what those funny little cells look like there, those are step pools that are being proposed for the river channel. And I'll show some pictures of what those might look like in a minute. But those are essentially boulders that are creating steps in the stream system with pools just downstream of that. So this is a system of riffles and pools, steps and pools, similar to what you might see in a natural steep system upstream of this site, very similar to those conditions. And this will allow water to flow through the river system and the energy to dissipate in these pools as it flows over the steps. The channel banks will be constructed of rounded stone. I should note that the rock being put into these steps and along the channel banks and the channel bed is rounded river stone, cobbles, boulders, gravels, not big angular riprap. We're trying not to riprap the stream here, but more stabilize with material that you see upstream of the Walter Hoving Road bridge there.
And what's kind of the likelihood of that all this material, especially like the rounded gravel and not riprap, but other items that you put in there, getting washed down as the debris got washed down, obviously, you know, in a big storm, or we're just going to be moving that slowly downstream?
Mm-hmm. Yeah, good question. So the boulders and the steps are designed, I believe, to the 100-year flood. So those are designed to be stable under pretty large flood conditions. The smaller material that is moving downstream that got caught in that pond, and in future floods, that will continue to move through the system. You'll find some in the pools at times, and during other floods, those might move through as well.
But will this design meter the movement of, say, the gravel and the debris that, as opposed to the dam, which retained it?
Right. The dam retained some of it. Some of it also went over the dam during those big floods. Yes, as I said, some of it will be retained in those pools. It's not going to stop all of the material from the mountains up there. There's a lot of material that's coming down during big storms. So you will continue to see movement of material through this system as it normally would.
But your design addresses that,
That's right.
to make sure that it's continued through.
Yep, continues to move through. Yep, that's right.
It continues to move through at a slower pace.
Right.
Additional inertia, basically.
What's that?
So it slows down the whole way down.
Yeah, so you'll get periodic movement of material. We can't say exactly how much is going to move at any particular storm and how quickly that's going to move. Depends on the size of the storm and what material is coming down. But those pools will hold some of that material during other storm events. As water pours over those steps, that'll continue to scour out and move downstream as well. So the finer grain materials, the sands and silts, those will certainly move through. Smaller gravels will move through. The cobbles and boulders, those are the ones that get stuck behind. And typically these steps do a pretty good job of retaining some of the bigger material that comes down, which helps to lock them in place as well. Yeah.
What's the material of the steps and the boulders along the banks?
Could we hold this, let him present
Sorry.
first and then, no, it's
Sorry.
okay. Let him get through it, because I have a whole bunch of questions myself too, so.
I'll remember that one though, thank you. So outside of the river channel, there's sort of a hatch mark on both sides. That's the floodplain restoration and also the area of channel fill. So the portions of the existing channel will be filled in with the excavated material for this new channel. The new channel will be about 30 feet wide and between 3 and 5 feet deep, about 3 feet deep at the steps and 5 feet deep in the pools. So it's a bit larger capacity. It's able to hold more water within the proposed channel than it is in the existing channel. You'll see a note about the stone footbridge to remain. There's that nice stone footbridge over the stream right now. The stream will be filled in, but that stone footbridge will remain, and the trails will work around that so that that is a feature of the site. Part of the coordination with the historical committees is to retain the walls of the existing channel. They're just going to be buried in place. There'll be a small portion that'll still be exposed above the fill area, but those walls will not be removed per their request. This is a little bit of what those steps look like. On the left side, you can see some boulders with water kind of spilling over there, over the boulders and into a pool below. Our stream channel, Phillips Brook, will certainly be much wider than that one, but that gives you a sense of what that step pool might look like. And just a bit of a look at what construction activities might look like. The stone channel bed and bank construction. What they're doing with the hose there is they're watering in finer material into the gravel and cobble, so it becomes a cohesive channel bed and channel banks, and you don't have water that goes subsurface and emerges up somewhere else. So that helps to keep all the material in the channel bed cohesive and water flowing over the top. The fabric slopes there, that's fully 100% biodegradable fabric, and that allows us to stabilize the channel banks and the slopes with seed underneath and plants that go through the fabric, and the fabric stabilizes in the near term, and then the roots help to stabilize long term. Okay, so that's kind of an overview of the designs. I know that many folks might be interested in some of the flooding and flood modeling and what the impacts of the dam removal might have on this system. We do flood modeling for all of our dam removal projects, and sometimes it goes the way you might expect it to go. Other times there are interesting results that come from it and surprises that come from it. For this particular site, I'm going to walk you through a few different slides here, and we'll keep an eye on the red title on the bottom, which says existing versus proposed inundation at the 1.25-year flood event. Just think of that as the 1-year flood event, and the next few slides will be larger, less frequent flood events. So you'll see more and more flooding on those. And the colors up there in the map show the sort of light blue or sky blue are areas that currently flood, and there'll be no change in the lateral extent. So the extent of flooding on the north or south side, left or right sides of the stream channel. The green color is where you would see an increase in proposed conditions in the flooding extent. So upstream of Avery Road here, you can see that there's an increase in flooding extent where the new channel is going, and a decrease where the old channel is being filled in, which is obvious. At this particular flood event, there's no change downstream of Avery Road. You'll also see that there are some areas outside of the stream channel in darker blue, and that's again decrease in flooding extent. So see few polygons along Snake Hill Road. So at this particular flood event, there's no water flooding over Snake Hill Road. This particular dam, it turns out, is in a spot that when it floods, it pushes water out onto Snake Hill Road and over to the south side of Snake Hill Road. And so when we go to the next slide here, this is the 2-year flood event, and we can see under existing conditions right now at a 2-year event, which is a flood that could happen every couple of years. It could happen every year. It's just a certain magnitude storm event that is pretty frequent that we might see out here. Currently, flooding extends over Snake Hill Road and along the south side through properties all the way down to the larger road to the west. All of that would be removed in the proposed conditions with the dam out scenario. So in this modeling, we would not see flooding over Avery Road and south of Avery Road during that 2-year flood event. Downstream of Avery Road, north of Snake Hill Road, you'll see a lot of the sky blue or light blue. Not a whole lot of changes here, but if you get into some of the details, there's minor places where there's a little bit of lateral change. Some places increases, some places decreases in those flood extents. As we move up to the 10-year, again, a whole lot more flooding on the south side, well, everywhere under existing conditions. So this is, again, you could have this flood every year for 10 years straight, but on average, this is every 10-year, so they're a 10-year flood event. Flooding everywhere downstream of Avery Road, across Snake Hill Road. Water is just going over Avery Road. It's going through the culvert, but it's going over the top as well. Kind of water everywhere. In this scenario, you've experienced this. I've seen videos of something similar to this. I've been there when there's flood debris up on the stone walls, so we've seen evidence of that. And with the dam out scenario, again, there's mixed results here with some properties seeing a decrease in flooding extents, some properties seeing a slight increase in flooding extents, some properties seeing both in the same property. But overall, downstream of Avery Road, we do not see an extensive increase in the lateral extent of flooding. Similar for the 100-year event, again, water's everywhere. You can see right around the Avery Road crossing, just north of the stream, a bit more green up there, so there's a bit more expansion of that flooding on that side, reductions in other areas, but this is sort of a really large flood where everybody's getting wet in this area under existing conditions and future conditions. Wrapping things up here, planting plan, we'll be planting the channel banks and the floodplains on either side of the river channel. Along the channel banks will be, that's the FES lifts, those are the fabric encapsulated soil lifts, those are those biodegradable fabric lifts. We'll be putting various species of willows and dogwoods in there through live staking, and there'll also be some native seed planted in there. And then on the floodplains on either side, a range of trees and shrubs to populate that area. It's going to be a mix of native plant species through this area. We will try to retain as many of the nice large trees that are there right now. There are a couple that do need to come down to construct the new stream channel, but most of those trees will remain. Again, impacts about 800 feet of the new stream channel, filling in about 300 feet of the existing channel. Overall, less than an acre of stream impacted by the project. We're finalizing the designs now and construction documents, and funding is in place, ready for bidding and construction as soon as we are able to receive the remaining permits. And with that, I will open up to questions. And Andy, I don't know if you want to take questions from the board first, or
Let's do questions from the board, and then we'll have SLR, who we had hired to do a peer review of the modeling.
So I have a couple questions, just more to understand the design of the new bank. So I understand the steps, and that makes sense to meter the flow and to kind of reduce the inertia of, flowing obstacles in there or material in there. So, but the side of the banks dictates the volume of water that kind of flows within the channel, and then at some point that it gets overflows, and that's when you start to see your 1 year to 10-year flooding.
that's right.
So how do you optimize or design the height of the banks? Like, so ideally you could make them super tall, and then 100% of the volume under a 100-year storm would stay, it would be a huge tank, or,
Right.
But then it would all go to Avery, Road culvert. So, and which obviously wasn't designed for that kind of volume. So how do you balance the design of the walls for the, the new channel against the, places where it's going to spill over and start to flood out in certain areas, like you really nicely modeled it.
Yeah.
But I'm just trying to understand, how do you ensure that your model that you built electronically then gets physically enacted when you get into the field?
Yeah. No, great question. So we are generally designing that channel to about the 2-year flood. So it will contain your annual flows. It will contain low flood events. The constriction on this site is that Avery Road crossing. So water will be moving through the new channel and then have to kind of pinch down to get underneath Avery Road there. As you said, if we were to build to the 100-year flood, you'd have levees on both sides, which has been happened across the country where we design those flood walls, but those would have to be really tall, and is not the desire of the project team at this point.
Right, of course,
Yeah.
So the culvert, is there a way to understand, can it handle the volume of a 2-year flood?
Yep.
Going through there, is that like within the design parameters of that culvert?
Yes.
With this new design, so it's kind of, I guess, partnered with the design so that it's not going to be overflown. So you're not changing the original design parameters that culvert was built for, I guess, is what I'm
No, and it's
saying.
still, the culvert is still going to back up under those large events, just like it does now.
Right.
So right now, when you see the whole floodplain adjacent to the channel, between the channel and Snake Hill Road, filled with water going over the Avery Road, it's because of that constriction currently. So that will still be there. During those events, water will still flow over the road and downstream properties from there.
Right, but you're confident that your design is not making it worse? It's within the design parameters
Right,
as
for
was
the
originally?
crossing, yeah.
Okay.
Yeah, and we did look into sizing that culvert larger, but because of wall widths downstream of the road crossing there, you can't make it so large to allow all the water to go through there for those larger flood events. So we didn't see any improvements in flooding extents downstream of Avery Road, even with increasing the width of that road crossing.
So that was going to be a follow-up question I had. So if you make that bigger, you're saying that now it just moves the constriction downstream?
Right. In a different world, different, different reality, when you don't have homes or walls downstream of Avery Road, you open up Avery Road to be fully extended, full bridge, and water goes through and extends out onto the floodplains, and that's what the river's supposed to do. River is meant to flood onto its floodplains, and so the channel, typically natural channels are built to that 1.5 to 2 year flood extent.
Other questions or comments?
How do you keep the walls in place? You said that it's wider and it's, the new channel, but how do you do that when you have to protect the walls from, you said they're buried? I don't understand
Yeah,
that.
so like if we look at this image here, the new channel will be a bit to the left of the image, and the material cut out to create that new channel will fill in this channel in between the walls. So what you'll see in reality is you'll see a river channel, and south of the river channel, you'll see vegetation, native vegetation growing, and you'll see maybe the top 1/2 foot or so of this wall, but there's going to be vegetation on both sides. And so retaining that, that little bit of the top of the wall was what the historical folks were asking for,
Right.
as opposed to complete burial or removal.
And that's what you were originally planning, was to remove the old wall and,
It's often what we would do is remove the infrastructure entirely, or bury it also. You could, it's all stone, so it's natural material, so you could push those walls into the area of the channel and just bury that and have that be floodplain material.
Anybody else? I have a couple of questions. Vis-à-vis the material behind the dam, I assume under the DEC had required test borings to see if the material is not toxic,
That's right.
et cetera, and I assume that came out
Yep.
fine.
Yep, all that was submitted.
And the second question is, it goes to a little bit to what Bob was saying. Is there we'll call it a monitoring plan over time, or will one be developed to make sure the new stream is not occluded in a major storm event?
It's a good question. It's not a plan right now, and it was not a condition of the state permit, but monitoring is something that we do on many of our projects, so that's certainly something that could be reasonable. I don't know where the funding for that monitoring would come from, but certainly that's not your concern.
Anybody else have anything right now?
Could you walk us through your thoughts on the construction sequencing?
Sure. So the initial stages, kind of setting up traffic control, setting up the staging areas and erosion sediment controls, all of that. Big picture, we've sort of drafted what we think is an appropriate approach, but before construction, we work with the contractor and they develop their schedule and their preferred approach, and then we work with them to finalize that and would submit that to the town for review. The nice part about this particular site is we can build some of the channel offline while the river is still flowing through this channel. So That would be the primary element of that sequencing is construct as much of the channel as we can before starting to remove the dam and filling in the old channel. And that way we can open up the new channel to water flow while we fill in the old channel and take down the dam. So there'll be some water control where the contractor will need to channelize the water in some locations or pump it to get it out of the impoundment so that they can take the dam out. But I suspect that they'll build the new channel first and then work to take down the dam, remove the sediment, and fill in the old channel.
What provisions will there be for like a storm event during the construction? I mean, that's obviously the
Yeah.
most fragile time frame, I would imagine. So do you have normal mitigations that you do for that?
Yeah, usually the contractor is required to manage the site for a certain size storm event. So need to have their machinery out of the river or out of the way for certain size storms, or manage the water with enough pumps or flow capacity for a certain storm. They certainly can't design anything to those larger storm events.
Yes,
So, you know, a 10-year flood that comes through is just going to come through, and then it'll be the contractor will have to repair, you know, anything that was damaged within the site there.
Yeah, I think that was one of the big question marks we still had, was the stormwater pollution prevention plan for the project.
Yep.
Especially even if you're creating an offline channel. I mean, the probability of hitting groundwater is probably still pretty high, and you'll have seepage that comes through and turbid water that needs to be controlled. Even beyond just the general construction of the banks and refilling the old channel and all that. So that's something that we are going to rely really heavily on in the future for issuing the permit once we get past this process.
Certainly.
To have a really strong SWIP in place.
Yeah, that's something that we have for all the projects. Typically, the contractor develops that, but we've talked with you about having us develop that, and we'll get that in place. Yep.
So the new stream, it's not between the dam and Snake Hill, it's on the other side, right?
It's to the north of Snake Hill Road. That's right.
So when you put that, you say you're gonna construct something there first and then pull the sediment out. How are you gonna get it through the new stream you just built?
Yeah, there'll be a little bit of challenging sequencing there of like what comes first, kind of a thing. And what typically happens for these dam removals on a relatively small stream is they're able to put up coffer dams and then pump the water around. So in this particular case, they'll probably have some continuously running pumps that move through 12-inch pipes, a series of pipes that will pump the water from upstream of the dam to downstream of the dam while they remove the sediment from behind the dam and then deconstruct the dam. So there'll be some period of active pumping water control and then some period of managing the water passively through either the existing channel or the new channel.
And that plan will be on, that's to come, and how are you gonna do that?
That's right. We don't dictate the means and methods for the contractor, so that'll be a pre-construction submittal that the contractor will develop with our review and the owner's review, and if that's a condition of the board, of the commission, then the commission can review that as well.
Thank you.
Yep.
Anything else right now? Okay, so the town had contracted SLR Associates to do a peer review. So I'm hoping that, Chris, you could come up and just give your findings. Thank you.
Do you want these as well? I got your own. All right, I'm gonna release mine. There you go.
No, that's not me.
There we go.
Good evening, Chairperson, members of the board. Thanks for inviting me to come talk to you tonight. My name is Chris Robbins. I work for SLR Consulting out of our New Paltz office. We, as does Nick, our water resources folks do this kind of work all the time. We design restoration projects. We review restoration projects. We do a lot of work with New York City Department of Environmental Protection and in the watershed and New York State DEC. So as Andy had mentioned, we were brought on to assist the board with a review of the modeling work that Interfluve, Nick's team did. Help you understand sort of what was done and how that sort of played out with regard to the processes and the results. So I'll run through that here now. A bit of background, as Nick had mentioned, Interfluve had developed a model for the project site that included Phillipsbrook Road, or Phillipsbrook and the dam removal. The model is a two-dimensional unsteady state model based on HEC-RAS, which is a modeling software that is used for these kinds of projects pretty much all the time, or most of the time. The model consists of a series of cells laid in a mesh. Those cells are about 5 foot by 5 foot in most cases, and with finer cell dimensions around the structures in the channel. And what that does, you lay that sort of mesh over the landscape, and that gives you the ability to model the conditions in the channel and outside. The existing condition was developed using the digital elevation model from USGS LiDAR. That data was supplemented with more detailed bathymetric survey that was collected on site. That bathymetric survey of the channel was superimposed on the digital environment elevation model. They looked at multiple storm events, right, as Nick had mentioned, 1.5, 2, 5, 10, 25, 50, and 100-year storms. And those were all determined using USGS regional regression equation method, and those were all modeled. So as Nick showed you, they went through the modeling for each one of those storms. The model was used to assess existing and proposed flood conditions within the project site, and you saw the maps that Nick showed you, right? The larger watershed extends beyond the project site. Generally speaking, the project site's between Walter Hoving and Avery Roads. Proposed condition that they used was based on a 75% design, which you saw in most of Nick's slides. And as I mentioned, SLR was contracted to help sort of review the modeling that was done, assess its appropriateness and the results. We did not look at the adequacy of the bridges and culverts. That was not part of our task. It was quite narrow to sort of an assessment of the modeling that was done specifically. The results of our peer review, SLR ran the model to ensure the accuracy of the output and existing proposed conditions. The existing condition model, just for sort of point of reference and of interest, the existing condition model took about 41 hours to run, and the proposed condition took about 31 hours. So it's a long process. There's a lot of data. These things take a lot of time to run. We hit start and walk away and come back, on Monday after starting it on Friday, and usually the modeling results are there. So, and as part of that, the model ran as we expected. As mentioned, the model captures Phillipsbrook floodplain and the inflow-outflows and within the boundaries. So the model itself encompassed everything that one would expect should be covered in this kind of a model. Model break lines were correctly defined along the significant features, the walls and roads. That's really what gives you some of the accuracy that you're looking for in the modeling results. Land cover and roughness coefficients, when you run these models, you look at, right, you've got all these characteristics. You've got a channel, you've got trees on the side, there's, you know, vegetation, maybe there's some roads, and there's a way to determine what that land cover is by observation, and then come up with roughness coefficients that you put into the model that allows you to get, you know, a better accuracy as you run that model. The methodology for bridges and culverts, as we saw it, was appropriate for what the model was to accomplish. Validation and calibration of the model output is not described in the report, but there are some limitations to doing that. So we did mention that in our report that Interfluve has. Existing conditions of the model, it's robust and suitable for what it is, the system that they're trying to model. So we agreed with the approach, the model type, and the like. There were typical minor computational errors, which are, as I say, typical. They come out in pretty much all model runs, and we bring that up because we found that those were reasonable, within reasonable tolerances, and that they happen mainly outside the project area. So those would result in no impact, or those would have no impact on the results that Interfluve came up with. Based on the runs and the design, SLR came up with a bunch of suggestions, which were passed along. One is to clarify the source of the DEM data. We're pretty sure we know what data that they use, but that should be included in the report and the documentation supporting the model. Clarify the extents of the bathymetric survey data and the LiDAR. A lot of times it helps to sort of understand, when there's sort of two sources of data, it helps to understand which area was modeled using which data type. So a line on a graphic showing what portion of the model was LiDAR and which portion of the model was based on the bathymetric survey would be helpful. At Avery Road, there were some inconsistencies in the model. There was some sort of, as the model ran, there were some unusual results that came out. They were not significant by any means, but the suggestions were, you know, you could improve that run by reducing cell size, ensuring cells are perpendicular to flow. The cell faces are slightly distorted and not perpendicular to flow in some cases, so that gives you that's you know, an adjustment in those will give you a more accurate read and results. Review of the 2D surface as terrain looks slightly unusual near the Avery Road crossing. Again, nothing significant observed that would influence the design. That was our takeaway based on our assessment. There was one anomaly that we found, and not sure sort of how it ended up there. There's a 2.8 foot drop in the model, at least as we saw it, and that was right near the Avery Bridge crossing, or the Avery Road crossing, and that should be assessed because based on our site visit, that does not exist. Other recommendation was, or suggestion was to review the model surfaces. There's a barrier included in the model that's basically a wall and fence, and that's included as an impervious surface based on our assessment, and the permeability of that is unknown and probably should be determined because it might affect sort of how the water flows through there and what the flooding inundation downstream of that would be. Use best engineering practices to accurately simulate the conditions under the flood, and then compare to past flood events if possible. Conclusions. Our assessment is that the model is consistent with 2D hydraulic modeling standards and best practices. The model that's selected was appropriate and it was run accurately. Review of computational output for both existing and proposed conditions indicates no significant errors or unrealistic results. Runs confirm the model is accurate and representative of both the existing and the proposed condition. And as Nick had mentioned, right, there was an existing condition that was run. The proposed condition is based off of that, so the fact that the existing condition model run was accurate means that your ability to get accuracy out of your proposed condition is greater. We did, as mentioned, there are minor modeling components that could be adjusted to more accurately reflect conditions at certain locations, mainly Avery Road crossing. And the bottom line, results in the model are satisfactory.
Thank you. Do we have questions or any comments from the board?
So, a nice summary. With these type of models, you have to make certain decisions and assumptions as you're putting the data into it and designing it, is the way I'm reading it from your summary here. And your team has looked at their model in detail and looked at both the model's design and the parameters that go into it and whether they're suitable or not, right? So you're assessing the kind of, I'm going to say, the quality or the best practice of the model itself from a peer company. Is that, would that be a fair assessment of how you look at your analysis?
Yeah, absolutely. It's a, you know, the model was developed, we took the model that was developed, ran it, looked at the inputs, and based on that, our conclusion was that it was the appropriate model to use for this condition, and the results were accurate.
Okay, so it's a way of quality controlling. You know, if I built an Excel spreadsheet and gave you a number, said trust it, you don't know what's in my Excel spreadsheet, whether I took shortcuts or what parameters I did. But here, you're coming in and you're checking those parameters, you're checking the model, making sure that, you know, it meets what should be done or what's best practices. So you're like quality controlling the work.
Correct.
Okay. Okay, and then, so you mentioned the next level, which would be validation. So is a model of this type, a hydraulic model, something that gets validated where you go to the, so I'm coming from the pharmaceutical industry, so validation means something very different to me, but I have done some modeling of equipment and things like that, and for those things, we do validate the model. So is that another level of what should take place here, or is that outside the scope of this type of work?
Essentially, our work indicated that the model that was run is the model that should have been done and run, and the results are accurate. So if, you know, as far as validation goes, if you want to say that it's, you know, we validated the
This
the
essentially
model
is the validation,
yeah,
right,
for
okay.
this
It's
use.
just a term, but it means
Yes,
something, yeah.
yes,
Mhm.
yep,
Okay.
correct. Good question.
Yep, thank you.
Yep.
Anybody else?
Yeah, maybe. The comment that you made about the 2.8 foot drop by Avery, could you explain that in detail, what you mean by that, or what it?
So in the model, and the person who ran the model identified looked to be a drop in the surface, the bed of the stream, right near Avery Road. Will that make a big difference in the results? Probably not, right? The water's still gonna flow through there. It's just that anomaly should be checked to make sure that if it doesn't belong there, that it's taken out and the models run, just to make sure that that inundation doesn't change downstream. We would not expect it to change by much.
Would it change, would it increase, does something like that increase the water flow through it, or?
Probably not. You know, it sort of depends. In the system, the depth of water is pretty consistent, right? You get the dam, the water builds up behind the dam, but most of the rest of the channel is pretty consistent depth. And so we wouldn't expect there to be a significant difference in what was done. It's just a check to make sure that, you know, it's accurate. And if for some reason it belongs there, they can let us know that.
Okay, and not checking the culvert, we had, that was we asked you to review this, but not the culvert.
We looked at the model itself. The model sort of takes into account the flow through that area, but we didn't look at sort of, our task was not to assess whether or not the culvert was wide enough to pass whatever flow was going through there. I mean, Nick mentioned it, I think most of the people here understand that that's, you can tell by looking at it, right, it narrows down. So, right, there's constriction there. We did not assess sort of what that would look like, what that should be. Nick had mentioned you put a span in, right across that area to eliminate that constriction point, but, so.
So would it be fair to say the way to think about it is, since, you know, design is a human construct, right? It's a tool we built to kind of model a very natural, chaotic flow. That's very hard to model, obviously, right? But we're trying to do that. So this tool that was developed by Nick, you've now looked at that, and you're basically agreeing with the results, the way that it was designed, and the results that come out. So there's another nice level increase of confidence around the design. Obviously, we don't know what we don't know, but based on best practices, the way this should be designed, you're increasing the level of confidence for the team.
Correct, and that was the intent of the conversation, right, why we were brought on, because, you know, I might sit on a board somewhere and we're talking about traffic, and I'm not a traffic person, so you have somebody else take a look at the traffic and say, yes, the traffic analysis was done, the roadway network was this, you did that, and yes, we agree with that, so that was the process here. Does that answer your question?
Yes.
Thank you.
Could we hold that for public comments?
Oh, I'm sorry.
Thank you. Anybody else? So, SLR's report was shared with Interflu. I assume you're going to address, you know, the minor. Is there anything else you want to say, or I don't think it's necessary at this time, but that's up to you.
Yeah, no, happy to. So
Please, at the mic. Thank you, Chris.
Thanks. Yeah, thanks for the review on that. That was super helpful. We passed along preliminary responses to the comments that were made. As was said, these models take multiple days to run, so they're in the process of being rerun with some of those modifications you mentioned. The 2.8-foot drop there at Avery Road, that was there when we first surveyed the site, because that area had some complexity with some deeper pools as it dropped off a concrete apron there. That all got filled in during one of the recent storm events, and so that hole is filled in. So in the model rerun, we'll just be using the most recent survey data in that area. Because both existing and proposed conditions were run in the same way with the same conditions, we're not expecting a real change there, but we'll be checking that and hopefully have results in the next few days. I think those are the primary ones to address.
Thank you.
Yeah.
So I'm going to open this up to public comment and questions. I'd like everybody who wants to say something to come up to the microphone and tell us who they are. But before we start, we only got one written comment. Is there anybody here from the Garrison Fire Department? Okay, so I'm going to surmise the conversation that we've had. We had received a letter about a week ago from the fire chief, Freilich, I believe is his name, that they were against the dam removal because they were worried that it would impact water supply that they use for firefighting. So I had replied back going, well, are you looking for a dry hydrant, which is something that you would put into a pond to pump out? I just brought it up. I didn't think it was necessarily realistic because we're dealing with a reservoir that's completely occluded. I did get a response back this morning, which is Philipsbrook originates from a water source north of the pond at the Garrison Fish and Game Club, located off of South Highland Road, through the pond and flows west along Philipsbrook Road. Additionally, the pond located at Route 9 and Snake Hill Road also follows west and meets Philipsbrook at the confluence in the vicinity of the Philipsbrook Road and Snake Hill Road, and continues as one stream flowing west. Water sites. Pond at Garrison Fish and Game Club, South Highland, Coyote Rise and Phillips Brook Road, Pond at Snake Hill Road and Route 9, deep pool at the Walter Hoving home upstream of the existing dam, Route 9D and Snake Hill Road. So the only thing that I would like Interfood to look at is, personally, and I think Max has looked at it too, there's a very, very steep gradient once you get probably about 200 to 300 meters north of the bridge at Walter Hoving home. I am not convinced, but I think this should just be looked into, that this would affect the levels of any of those water bodies or water courses. Okay. With that said, who would like to say something first? Don't be shy. Thank you.
Oh, okay. I have many questions. Hi, everybody. My name is Maki. My question is for you. If you were a doctor and you were giving me that diagnosis, I'm going to get a second, third opinion on that one. But I think that he clarified the fact that you guys are rerunning the data, because I was freaking out about this data. But my question to you is, you noted a 2.8-foot drop in the channel file near the Ivory Road, and you're asking, you're revisiting that situation. I know that he clarified it, but is it because it's based on that, or what you know right now? Could that drop cause water to back up or overflow in a way that the model isn't showing yet? And would that change the flowing boundaries for nearby homes? Because he mentioned earlier in his presentation that some houses in the 10-year and might get less flow or might get more. In other words, they might be affected differently. I'm just a little concerned about this data and how it's going to really be cleaned up a little. So just if you could help me out with that, thank you.
It should go to, yes, thank you.
Good question, and I'll only surmise right now because we're in the process of running the model, so we'll be able to tell you the actual results soon. But once floodwaters rise above the elevations of the channel bed and fill in those pools, that what could have been a 2.8-foot pool if in the before it was filled in with material, the water is just flowing over that, and that sort of a drop right in that area is similar to a natural riffle pool drop that you might see in a stream channel, but once the floods get high enough, it's really not being impacted by that drop. So the water levels won't be impacted upstream or downstream by that particular drop at certain flood events. So I would guess, based on our experience, that once you get to that 2-year flood, 5-year flood, 10-year flood, those irregularities in the channel bed that you have in natural channels and that we see here are not playing any role in the extent of flooding or changes in elevation of flooding.
So we shouldn't worry in 100 years from now that this is, you're not concerned about that because your data is clean.
That's right.
Or will be clean, because obviously I was a little nervous.
Yep.
It will be clean and it won't affect the lack of water flow for
Right.
like what they mentioned with the fire department, the houses and the nearby surrounding being able to either not have a flow happening because of this new renovations or
Right, that too.
liability being taken away. So, we just want to make sure that the liability is stated in the sense that it is also not liability for your company, but also for the people's, community and the houses around it.
Sure.
We just want to make sure that this data is
Accurate. Yeah, Understood. So, yes, we're remodeling that. As I said, I don't think that 2.8 foot data piece is going to matter much to the flooding extent. We did check other data between the two surveys to make sure there wasn't a bust in the survey. If everything was off 2.8 feet, that would be a concern, and it wasn't. So that led us to look at past pictures, and we could see a pool in that area that was that difference in 2.8 feet. So that's just the channel being filled in with sediment and gravel over time.
And
So-
excuse me, would you say that you were comparing apples to apples? I know this is more than one question.
Yeah.
Okay, great.
Yep, absolutely. So the existing and proposed conditions had that same data in it for both of them. So when we rerun these models with the refinements that were mentioned, it's going to be the same for the existing conditions and the proposed conditions. So you're always comparing the same thing.
I look forward to hear that.
Yeah, absolutely.
Thank you so much for your answer.
You got it. Thank you.
Thank you. Other, please?
Hi, everyone. My name is John O'Rourke. I'm not sure these are on, but I grew up on Avery Road and Snake Hill Road. I own a civil engineering firm. I did a year of research in CFD. There's a lot of that today. My questions are much less about the exquisite details of the CFD modeling that we've done tonight, and more about the ecologic benefits, largely what's the benefit of removing this, in so much as have we modeled the biodiversification or any benefit along those lines, composed against or juxtaposed against if we didn't remove that, and then completely different than that, have we done a structural analysis or civil analysis of the spillway to see what risk it is of collapse? It's stable. It has been there for a substantial amount of time. There is like elements of undermining, but without a greater analysis, I think we're proceeding with this because there's funding from the state and they're pulling these down all over. But have we run a cost analysis and also a subsequent like ecological analysis that could be kind of coupled with the cost analysis of leaving the dam and system and its removal? I don't know. It's a lot. Most of this has been about water flow, but I'm kind of curious about the benefits of what if we just left it?
I'll keep speaking into the mic, whether it's on or off. Thanks for the questions. Great. So from the ecological standpoint, dams present barriers to fish and aquatic organisms. Fish and aquatic organisms cannot move up or downstream of areas with dams or perched culverts or other barriers. The water that is held behind dams typically heats up in the summertime in particular and reduces the water quality of the water that then flows downstream. Reducing the water quality of Phillips Brook. Now, the impoundment behind this dam is very small. It was before it filled in with material, and it's even smaller now, so that may not be as large of a concern here, but generally, these systems impair the water quality of the rivers. Increased water temperatures, reduced dissolved oxygen, increased vegetation growth in the impoundments can lead to algal growth as well. So there's ecological impacts there. By removing these barriers, we can allow the more natural movement of water and material and organisms up and downstream. There are other barriers on this stream system downstream of Avery Road. This frees up 4 barriers. It removes 4 barriers to flow. In particular, DEC is funding this project to remove barriers for that ecological benefit, in particular for American eel on this system, which are able to navigate some vertical structures that have water flowing over them and have some texture. They're able to navigate some pretty steep structures. So this is an opportunity to potentially allow American eel to continue moving up into these systems, but also resident fish and other organisms to move up and downstream.
Can I quickly follow up?
Sure.
At the bottom of this stream, there's a 50-foot waterfall. Have we studied whether American eels can traverse that waterfall?
We know that American eels can traverse barriers of that height. Studies on this particular river I have not seen, and there have been no models, ecological models of this system, no, that I know of. And we have not run any ecological models in this system.
There's been anecdotal evidence from Constitution Marsh Audubon Society that eels have traversed above Indian Brook waterfall, which is just north of Phillips Brook. So we do have data on that had been collected from their staff years and years ago. But
perfect, thank you. So. Yep. So American eel are amazing. They can get up these structures. So again, there are other resident fishes that are in this system that are blocked by those barriers. So it allows for that movement. It also provides more habitat along the stream banks, and more natural stream bank habitat for other organisms that might be in the area, whether those are turtles, amphibians, whatever they might be that live along stream banks. And as we've seen in other projects around the region, removal of these barriers brings back the life of river and riparian ecosystems. So it's amazing to see the life that comes back into these areas with fish, with birds that prey on fish, and with dragonflies that might be in these areas, and other organisms. From the structural civil analysis piece, we did not have structural engineers have not assessed the structural stability of that dam, unless somebody did before us, Beth. I don't know what the dam inspection.
We didn't do it with the dam, but the reason that we,
Could you come up?
yeah.
Oh, sorry.
So the main reason that we decided to kind of talk with Interfluve is in 2011, we had the big storm.
Yeah.
Right? Filled a lot of sediment. The road collapsed, we all know, on Snake Hill. It collapsed, it came into our pond. 2012, we had the next big storm. We had Sandy, right? That road collapses again, everything comes into that pond. In that storm, the drain for that pond got broke. We cannot drain that pond. That is where we began to try to study how do we even clean that and try to keep it, because the drain will not open anymore. And it got damaged in that storm. I've had multiple people come out and look at it before I hired Interfluve. I did not hire someone to see if the dam was going to break or not. During those two storms, y'all have seen it, the sides started collapsing, the dam started having holes in it, the sides are collapsing, and I'm just looking for a solution that honestly we could afford. This is not a cheap project, and that one that would work to restore either through a dam removal and a restoration. We just felt it was the best way to go for us for multiple reasons, but really it was 2011 and 2012 that really just jammed us up in being able to do anything to remove sediment. In the 2012, the county came. As you know, there's a lot of restrictions on that stream. So you can only work from April to September, correct? So other than that, you can't touch the water with machinery. Even when you're in it, the machinery can never touch the water. A lot of requirements. And so even when we would dredge, it would be months of just planning, a tremendous amount of money. And when we couldn't get that drain open, there's no way to dredge. So the county in 2012, all the permits were listed because of it being a natural disaster. FEMA came in, so the county started taking the sediment to fix the road. Halfway through, it came back, the restrictions came back, and Putnam County said, we can't take any more. And so we were just still stuck without being able to get to our drain. So that's kind of where we enlisted the conversation of how do we fix this and what is the best way to do this in a way that we, as a nonprofit, could afford.
Go ahead. Yep. Can you, yes, would you come up, please?
Myers, I live across the street. You were talking at the last meeting about the Avery Road culvert being the main problem,
Okay,
and that you were investigating some
so
funding.
we spent $200,000 to evaluate Avery Road culvert, okay, as Hoving Home, okay? So, and there's not enough room to widen it. No, Nick, you have to help me here because you were the one that did the study. So because of the property lines and where that is, you cannot widen that culvert. So it's in good enough shape to keep. We actually did the whole report. The town board has it. If they want to do the culvert, I don't own the culvert. I can't do anything with the culvert. The town has decided not to do anything with the culvert, which is fine. They have all the paperwork if down the road they want to and all the studies. But there was nothing, and you know, even had some of the funding if it decided, but it was decided that the culvert, us doing anything to it would be minimal and have no benefit. I mean, we did $200,000 study.
Everybody says that the culvert is the problem, though.
But the culvert is the problem because as you go a little farther down the stream after Avery, it's constricted. It can't go any wider because there's homes and there's walls. So if you make the culvert wider, it's not going to fix any of that because the culvert goes, and if you go further down, those walls are falling down, like as you're walking through some of those properties. And so, the culvert doesn't change that because we can't go wider because of the constriction of that next channel.
So has anybody been able to say between the proposed and the existing, is there going to be more water on these properties that are south of Avery Road?
Okay, so he
There's very,
okay.
I've got pictures of Sandy. I know
Right.
exactly where it floods.
In a 100-year storm, there's just going to be water, right? But in the smaller storms, you did see on the models some, and I did write everybody that has property on the stream, and I have it that are farther down, and if you're here tonight, I'll give it to you. I've got your parcels, and it shows either no change, increase, or decrease, and where that changed. I had sent out a letter to everyone and said, if you want it, I'll come meet with you, show it to you. You're not on the channel. It doesn't affect your house. And so there was no need. So anybody that's here tonight, if you live on that channel, I have those and brought them with me. You can have them and go take and study them, talk to me or Nick. Nick, I hope I explained that well enough. Okay.
That was great. And I think to your point, at those different flood events, different properties will be impacted differently. Most properties will see some areas of increase and some areas of decrease. The flow is really complicated around all the structures and the trees and everything else that's going on there. And so at each location, some properties will see general decrease. Other properties will see a little bit of an increase. But as you saw with the maps, there's not an extensive lateral increase in flooding.
So number 1 and number 7 are not going to see an increase in water?
It depends on the parcel.
Number 1.
What's number 1?
Those landowners are here. I'm happy to share the maps.
Ah.
And you saw that on the display. Yeah.
Right.
It's on that.
So that's the just downstream on the left side. They're the one, they get flooding right now. Water pours right down their driveway, over the walls. It goes down Snake Hill Road and then through the fence downstream of that area. So that is a location. It's hard to tell the detail on the map. It doesn't change a lot because it's going to keep flooding in that area. That property has some areas of increase and some areas of decrease on that one property.
Which one, 7 or 1?
Sorry, one. The one just downstream of Avery Road.
You guys told us that the validation and calibration were not consistent. You know, he kept using, you know, if I was going to hear what my results of the test were, if they were not consistent, So, but your bottom line is that the results are satisfactory. When I got a satisfactory grade in my school, it was 70. I got a C. I made it. Would it be fair to say, that you guys are coming back with this more reliable data so that, people like the lady behind me could feel more confident that it is not based on your experience? I appreciate your experience. It sounds like you really are giving us, more of your experience. I think that we also need to hear, what is really going to happen, and ecologically speaking, is that really necessary? When you actually show numbers, for the gentleman back there that we're talking about ecologic effect, they don't lie. So I'm sure that we will have a fantastic, more than satisfactory presentation about this, because it is important, right?
Good one. We've done some peer reviews in the past, and generally, we're not telling anybody that they're fantastic. That's not something that we do. We're not telling them that they're great. We're not telling them that their model is the best we've seen. Satisfactory means that it's met the professional due diligence and the standards of practice. We're not giving judgment one way or the other than reviewing the model. And so.
So you're just running it because you just want to run it again? You got.
Nope. The points that were made were valid points, and we want to check. And that's why I said before, I can't give you the actual result right now. I can say what I think based on our past experience. But certainly these are complicated models, and nothing we do is perfect. We're not going to get perfection. And so it's really good to see somebody review, and the fact that those minor points were all that were found, that to me is excellent. And those little minor points, I'm not expecting to change anything at all. But we'll see.
Thank you.
That's what we'll find out.
Next, please.
My name is Ray O'Rourke. I'm an adjoiner on Snake Hill Road. I have a question that hopefully moves us slightly past the models. It's really one of aesthetics. Nikki referred several times to the historical people, and my question has to do with the stone footbridge that will be preserved at the site. There are, in fact, 2 stone bridges there, both of which add to the character of the surrounding area. Is it the case that one of those 2 stone bridges is going to be removed? If that is the case, is that an essential part of the project, or could both of those stone bridges be preserved? And if I might, Nick, if you just hold on, and I also have a comment for the chair. With respect to your question about whether or not the step pools will ultimately be occluded with the cobble, silt, and other things that run down the stream now, I'm not an expert, but I will give you a projection. As long as the town continues to dump item 4 on Philipsbrook Road, adjacent to Philipsbrook Stream, and cuts sluices into the roadway to more efficiently drain that item 4 into the stream, then those step pools will become occluded. Nick, so I'll leave you to the question about the bridges.
Yes. So those footbridges, as you mentioned, one is being retained where the channel is being filled in. The other stone bridge needs to be removed because it's where the new channel is coming in, and the new channel is much wider than the existing channel. So to maintain the proposed channel width and to contain the waters that we want to contain within that channel, that stone bridge is going away. Unfortunately, yes. Yeah, and there will be we're developing a sign, historical sign with some photos and historical context that will be on the property as well, that will likely speak to the construction of those structures.
I have a quick question. Is this all going to be open to the public, or is the public going to be allowed to walk along and go on the bridge? Are the neighbors allowed to enjoy this?
So we are a private nonprofit, and we do serve women with very sensitive and vulnerable backgrounds. So currently, neighbors walk their dogs on our property. They just don't go up the hill. And we've been fine with that, and we'll continue to be fine with that. But we are very careful. I'm not going to let somebody have a party unless they call me and ask if they could have their family party, and I give approval, and I've done that before. So we don't care if neighbors walk. Strangers will ask who they are, just because of the women that we serve and the past that they have. So most of our neighbors know they can walk their dogs on the property, and they do. And they used to walk in that area. I think, Eddie, you used to swim in the pool. And the pool had to stop being a pool because of public policy in Putnam County. They said if we couldn't surround it with a fence and we couldn't get a lifeguard, it couldn't be a public pool anymore. And that happened well into 18 or 19 years ago. So that stopped being a pool long before it got sediment. So that was something that had to be stopped. Our women could no longer swim in it. And I understand the sentimental value. I've been here 34 years. I used to swim in it, right, when I was first at Hoving Home. So I understand that. And but as far as neighbors, no, I wouldn't say that I want it put on any public thing saying that tourists can come walk our property. But yes, the neighbors can enjoy it.
Thank you.
I'm Eddie Barry. I live at 71 Avery. And first of all, I want to thank every neighbor for showing up here tonight, because I think it just shows how we are all caring about what's happening in Walter Hoving, right? You cannot ask for better neighbors from everybody in this room, including the folks at Walter Hoving. And yes, I walk my dog there quite frequently. That being said, so Nick, a couple of questions for you. The first one is, how do we make sure that we're not just moving the problem by, removing the dam, right? If that sediment is, as Mr. Rourke said, Ray said, hey, the sediment's just going to keep moving down, right? Are we going to have that sediment build up at the culvert or even further down? That's question number one. To address what was said earlier, because I walk my dog there every day, I can tell you that I've seen that dam shift. It's shifting quite a bit over the last 10 years. Now, is it going to collapse in the next 10 years? Don't know. But if I was a betting man, I would say that it's more likely that dam is going to collapse before we have a 10-year storm. That's just my own personal opinion, just from what I see there. And if that did happen, it would be a different conversation we'd be having here tonight, because then it would be, all right, what do we do with all the water that's happening every storm? So my two questions are in regard to the sediment being moved. I think everyone has their own opinion about the dam itself remaining there, whether it's going to collapse or not collapse. The second question I have is, you mentioned a 30-foot width and a 5-foot depth for those stones being moved down. How did you come up with that 3 to 5 foot depth for the step stones, and why wouldn't it not be deeper to address the 10 or 100-year storms? Those are my questions.
Thanks for the questions. Let's see, which one to go first. Sediment in this river in Phillips Brook, where this particular site is, it's at the base of really steep watershed that's coming down. And historically, if we were to look at this area, there's an inflection point right about where this site is, where the dam is, in that river profile, where it's really steep and then it gets less steep. And that is an area naturally where it would have deposited material, and channel probably would have moved frequently through that area. So what we're seeing with all this gravel and cobble coming downstream is not unusual. That's what we would expect in these steep streams like this. With the dam, if the dam were to stay in place and we were to have another storm, that material would continue to move downstream, up and over the dam, and downstream as it would. With the dam out, material will come down, it will move through our stream system, and it will move into downstream sections as well. Again, I can't say how much will move under which storm and when and where it's going to deposit. The whole system is pretty steep, so you'll get some material that is captured in the pools, some material that might get captured further downstream in pools that are downstream. So that's sort of the natural movement of that material. The pools within the design channel area were designed to be 5 feet deep as, well, you can't go so deep with that kind of a channel width. So if we go 10 feet down to have a stable slope on the side, you'd have to have a really wide channel. And so that's about as deep as you can go for that kind of a width without having vertical walls on the side. So there's some balance between a channel bank slope, which we typically have at about 2 feet horizontal to 1 foot vertical, so 2 to 1 slope on the channel banks, and then that deep pool in those areas. Can't go a whole lot deeper without going more vertical on the banks there. And the 3 foot depth is where the steps are themselves, so that's where those larger boulders are between the channel bed there and the top of the bank.
Okay, sorry, one more thing. The trap doors or the dam mechanism is, you used to be able to drain it. Is that where the new floor is going to be?
Yes, the new channel will go right through the dam there and then start to move a little bit north of the existing channel downstream of the dam. Some of it comes to that sequencing that we talked about earlier. It is generally easier to build a channel offline, off of the existing channel, so that you can have the water flowing through the existing channel and build in the dry and build in dry conditions. It also adds a little bit more channel length, a little bit more channel width, so we have a bit more habitat opportunity through those areas, more pool habitat areas.
Next, please.
Hi, thank you. I'm Owen. I live nearby to the creek, Sullivan Hoke. And just to speak to the ecological benefits a little bit from my anecdotal, from my experience, there's a brook trout population in the Phillips Brook. It's now dwindling, but I know that it used to be significant, and I've seen almost caught a brook trout actually in this exact stretch that we're talking about. I haven't seen a single fish that's other than, like creek chub since then, with all the sediment deposition impacting, spawning and the migration of these fish. So in that sense, I would really like to see this, these pools, these deeper pools with more dissolved oxygen, and this gravel bottom seems more preferable for spawning. So I'm excited about that, but I do have a question about if there are all these invasive reeds above the dam, and that what used to be a pool now it's just sediment basically. Is removal of invasives at all incorporated into this plan? Because that would that's also a significant impact on these fish populations. And other than that, is this new bottom, like this new gravel material that you guys are planning on putting in terms of the actual stone that's being used and the size of it, are ideal environments for fish spawning in a factor in determining the size of the sediment or the type of sediment, and will these fish be able to potentially in the future make beds on in this sediment? Thank you.
Great questions. The invasive plants, first of all, for the material upstream of the dam, all of the material where the invasive plants are will be excavated and disposed of off-site at an appropriate disposal site. Other material that does not have invasive plants in it will be reused, so the gravel and cobble will be reused in the channel bed and banks. But any invasive material will be gone. And typically for these projects, we have a 3-year warranty for the contractor that they need to maintain a weed-free site for 3 years after construction. So if there are invasives that pop up, they would be required to manage those through those 3 years. Regarding the spawning gravel, really good point. We always try to use rounded river stone for that material that goes into the channel bottom. So it'll be rounded gravel, cobble, and boulders in a gradation, so it's not just big material. And in those pool tailouts is where you'll see the reds, hopefully, for the spawning trout. And the material should be arranged enough for them to be able to build their nests there. Yeah, good question.
May I ask a question? Where will you get the stone? Where do you find rounded river stone? Is this a New York product? Is it regional? Is it shipped in from Colorado?
Yeah, good question. So again, we are typically not dictating where the contractor gets them. We just dictate the type of material it needs to be. Usually there are sand and gravel pits in areas where they're being mined for other purposes, and often the rounded stuff is stuff they don't want, or they're grinding it up for stone dust or other materials. And so usually the contractors will work with them and say, hey, keep out a whole bunch of the rounded stuff of this particular size. Okay. So usually it's somewhat local. It depends on what the bedrock and rock material is around them.
Hi, I'm Jim O'Rourke, and I'm the last of the O'Rourkes. Beth is a great neighbor. I have just a couple questions actually I have a few questions. Number one, the bridge east of the containment area, that bridge, does that stay? Is that impacted at all? Okay. Both of the bridges, as you just clarified, have to go. My understanding from... I'm sorry, one of the bridges have to go. Which one? One for...
The lower one goes away.
The lower one goes away. Okay. Now, back to my original question when I was in back, what's the material for the big boulders? Is it are they natural boulders, or are these cement made to look like natural boulders?
Natural.
These are natural boulders that they're going to put in, okay. And then there is a dam, there is a spillway dam north of the main dam that holds the pond in. Does that stay or that go?
That's one that goes away also.
That goes away. Okay, and I agree, the dam, your point about the utility of the dam was to form a swimming hole. Nobody swims in it anymore, so the utility makes good sense. I asked the board to scrutinize carefully the need to change the scope of the downstream area within the two walls. And I'm not sure I understand how you're going to do that. You're going to keep the top of the walls so it just doesn't make sense to me. It's hard for me to get my head around aesthetically how that's going to work. You can leave one wall and take the other wall out. I know you talked about stones on the side. I'm just trying to get a sense of what that would look like. And I'd ask you to scrutinize whether moving it to 30 feet is necessary. It sounds like you could save a lot of money without changing the scope of that and just fixing those sidewalls. So, thank
you. The channel width goes back to the modeling exercises and trying to contain that 1 and 2 year flood event within the channel boundaries, which we can't do with a narrower channel as it is. It is a little bit weird to think about a new channel going in and what's going to happen with the old one. Where the new channel exits the existing channel, those walls will need to go away. So and then when the new channel comes back into the existing channel near Avery Road, it'll need to break through the wall, so that wall will go away. But in between, where the new channel is completely offline or separate from the existing channel, those walls will essentially just be buried in place with a little bit of the top exposed on top. So you'll just see a flat floodplain with a little bit of the stone on top sticking up above the ground, and the grasses and the flowers and the shrubs.
If you don't mind. So just so, because it is hard to get my head around
Yeah.
why you're taking out away the dam, and it makes good sense. Then you're making a right turn, going straight, making a left turn, and coming back into the channel to go under. It does seem intuitively to be
A little bit strange. Well, to us, straightened river is a little bit strange, right? And so rivers are meant to have bends in them, meant to have turns in them. These aren't hard angles, hard right or left turns. It's a little bit of a squiggle in the stream channel to get a little bit of additional channel length, dissipate the energy a little bit more, get ourselves a little bit more channel width for capacity in the channel itself.
And finally, the bridge that stays will now be walking over dirt.
Flowers, yep, dirt and grass and flowers. That's right.
I just wanted to make sure I was clear on that.
Yep.
Are there any other questions or comments?
My name's Rodney Tudor. I live up the hill from, actually, my parents used to live right behind them. And for full disclosure, fantastic neighbors, absolutely fantastic people. As a kid, I used to swim in that hole. And I still remember, I think it was the Bentons. I used to get this little yellow sticker to get permission to go swim. And then there was an incident, and that all came to an end. And I wasn't involved. And for further disclosure, I am a member of the fire department, and I think what Fred was trying to ascertain was, is there going to be access to the bed, or the stream bed, in case we need to draft from it?
Yeah, I mean, the fire department could still have access. And I don't know if y'all know, we do have a 20,000 gallon reservoir on our property, and that's always accessible if there was something to go wrong. Yeah, 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 absolutely. They can still take water from the stream. I mean, yeah, that's not a problem for us.
And I think one of the reasons we're here is the lack of maintenance of the stream. Over the years, it goes back further than 10, 15 years. I mean, it's been silting in for a lot longer than that, and if it was maintained, it'd be in a different spot. I know there's people that love to blow up dams, and that's probably why you're here and happy about it. If maintenance was done, I don't think we'd be here. So what maintenance is going to be done in the future that's not going to bring us right back to here where the flood's going to keep coming? I personally don't think this is going to stop the flooding, because you're going back to a bottleneck at Avery Road. It's just going to slow the flooding in a different way.
Well, the model shows that it's going to flood, right? So
It's not going to change anything.
Yeah.
I'm not against, they can do what they want to do with their property, but it just doesn't seem.
But it prevents the catastrophic breaking of the dam, which from
Yeah,
somebody's point of view before sounded
It's a
like
safety
there was a
issue,
lot
you
of
gotta
damage
take care
to
of
it.
it. I understand that.
It's also a channelized system, which is unnatural. So
Yeah.
before that was built, I'm saying probably about 100 years ago, the area did flood. The stream probably, because it's a flat area, probably curved and formed
We
alluvial
moved here in
fans.
'75, and
So-
the flooding's only been in the last 30 years, maybe 20 years.
Well,
it wasn't when the maintenance stopped and the flooding started.
We also have had 100-year storms every 5-6 years.
Yeah, we had 300-year storms in the last 10 years. You're correct.
Whoever designed the original, channel probably didn't run 2 computer models on it, so.
I'm sure. But anyway, I just think without proper maintenance of the new stream, we're going to be in the same boat anyway.
We'll certainly look into that. Any other questions or comments? Okay, with that said, a question for council. I assume that we can vote to close the public hearing.
Yes.
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 So what will happen is, we will post these two presentations on the town website within the next 24 to 48 hours. We'll also post a notice that if there's other public comment, written comment, that we'd like to get that, I guess, in the next 14 days.
Yes.
Yeah, right? And then at which point, we will put together the materials that we need for the CEQA process. And at our next meeting, we will have a resolution to look at this as a unlisted action, and most likely look at this as being a negative declaration, just what the state did. And then we will go on to developing a conditional permit. And it will address many of the comments that you brought up, and we have a whole bunch of other comments that we'll want. So with that said, could I get a motion from somebody in the board to close the public hearing?
I make a motion to close the public hearing.
Second?
A second.
All in favor?
Aye.
Aye. And I need another motion to adjourn the meeting.
I'll do that too.
Okay.
Make a
Second,
motion
all
to
in
adjourn
favor?
the meeting.
Thank you, everybody, for coming.
Thank
We
you all for
greatly
coming out.
appreciate it.